What we want to do now is work with some complex fractions. Complex fractions are fractions that contain other fractions in their numerator or denominator. Let's look at the first one. 3/4 divided by 1/8. This is a complex fraction. Let's just use our definition of division. This is 3/4 divided by 1/8. So instead of dividing, I'm going to multiply by the reciprocal, 8/1. Now I'll reduce to lowest terms. 4 divides into 8 twice. I have 3 times 2 is 6. Divided by 1 is just 6. So one way to simplify complex fractions is just to use the definition for division. Think of it as 3/4 divided by 1/8. Then instead of dividing by 1/8, we multiply by its reciprocal, 8/1. Our next problem looks like this. In order to use that definition I used on the first problem, I'd have to simplify the numerator and simplify the denominator separately. Instead, what I'm going to do is look for a least common denominator for all the little fractions that I see. That least common denominator will be x times y. I'll multiply the numerator by it, and I'll multiply the denominator by it. I know that won't change the value of this rational expression because I can multiply the numerator and denominator by the same amount, and that's my property of fractions. But what it will do is clear this of any complex fractions or any secondary fractions that I have. xy times y will be xy squared. xy times 1 over x, the x's will divide out and I'll have left just y. In the denominator, xy times x is x squared y. And then xy times 1 over y, the y's will divide out and I'll have left just x. Now from the top, let's factor out a y. So I have y times xy plus 1. And in the denominator, let's factor out an x. I have x times xy plus 1. That factor is common to the numerator and denominator, so this results in just y divided by x. Okay, so a second method of simplifying complex fractions: find the least common denominator for all the little fractions you see, multiply the numerator of the complex fraction and the denominator of the complex fraction by it, and see what you get. Let's try a second problem, or a third problem, I should say. This one's all set up to do by division, so let's do that. This is 1 over a plus 2 times, instead of dividing by this, I'm going to multiply by its reciprocal in factored form, a minus 3, a plus 2, all divided by 1. So a squared minus a minus 6 factors into a minus 3a plus 2. So I did two steps at once. I changed from division to multiplication by the reciprocal, and I factored that expression right there. Now the a plus 2's divide out, and when I multiply, what I have left is just a minus 3 over 1, which is just a minus 3. So here I used my first method again, where I think of it in terms of division and change division to multiplication by the reciprocal. One last problem. This one looks like it would be easiest to do if I find a least common denominator. The least common denominator for all these denominators is y squared. I'll multiply the numerator by y squared and the denominator by y squared. That won't change the value of this expression, but y squared times 1 is y squared. Y squared times 9 over y squared is 9. Now, y squared times 1 over here is y squared. Y squared times 1 over y, that factor of y divides out with one of those two factors of y, leaving me with one factor of y. And y squared times 6 over y squared, just 6. Okay, numerator factors, y plus 3 times y minus 3. Denominator factors into y minus 3, y plus 2. My y minus 3's divide out, and I have left the fraction or rational expression y plus 3 over y plus 2. Okay, so there's a look at simplifying simplifying complex fractions by using two different methods.